So here we have an RC circuit with voltage source and current source. So the question is to find V out of the circuit, which is across the capacitor. So this is the V out, voltage across the capacitor. And in this circuit we have initial conditions. So the initial condition is 5 volts. Okay, it means that at t equals to 0, okay, and initially the capacitor has 5 volts stored in charge, right? So we have to determine the V out of the capacitor. Now, as I said before, that the first step is to convert or transform the circuit from time domain to S domain or frequency domain. So you can see here, as usual, the resistor still the same in both T and S domain. Okay, however, the voltage source, okay, 10 E minus TUT, we can transform this, we can refer to the Laplace transformation table to convert or transform 10 E minus TUT into 10 over S plus 1. Okay, this is straight from the Laplace transformation table. And then we have 2 del T here. Okay, so same thing in Laplace transformation table, 2 del T here, we get 2 ampere. Alright, there's no S in this voltage current source. Okay, so next is the capacitor itself. Capacitor is 0.1 farad, and we know that to transform the capacitor in S domain, the equation is 1 over SC. 1 over SC. So C is 0.1, so therefore we get 10 over S, which is here. So this is the value of the capacitor in S domain. And then do not forget that the capacitor has initial condition. So if we can recall initial condition for capacitor, right? So if the capacitor has initial condition, that initial condition can be represented as voltage source or even current source. So if the initial condition is represented as voltage source, then we can see that the initial condition value is V0 over S. Alright, so in that example, the V is 5, so 5 over S. This is if the initial condition is represented as voltage. However, if we want to represent it as current source, then the current source must be connected in parallel with the capacitor, right? This is connected in series, this is connected in parallel, right? So the value of the current source due to the initial condition is C times V. So we have to calculate based on the capacitor itself, 0.1 times 5. Alright, so it's 0.5. This is the current source of the initial condition. Let's go back to the circuit. So here we have the initial condition represented as the current source, right? 0.1 times 5, and then we have the capacitor, right? Now we want to solve for V out T. Okay, but before we can get V out T, we need to get V out S. Right, so here this is the V out S, alright, which is from here to here, and this is all we assume is connected to the ground. Okay, assume this is ground, which is 0 volt. So this is 0 volt, right? So here we need to find V out as our voltage across the capacitor. So based on this condition of the circuit, one of the best way is to use nodal analysis, right? So based on a nodal analysis, we need to calculate the current in and out at this node, right? So we can see here that this current is going in, this current is going in, this current is going in, this current is going out, this current is going out, right? So these are the currents that going into the node, and these are the current that are going outside the node, right? So you can see here, so we have to calculate one by one. So what is the current? This current is voltage, this voltage minus this voltage divided by the resistor here. So 10 over S plus 1 minus V out divided by 10 ohm. So this is the current for this one here. And then these two are the currents that also going into the nodes 2 and 0.5, right? Next is the current going outside the node, away from the node. So this one, which is V out minus 0 divided by 10 ohm, V out minus 0 divided by 10 ohm. And then the second is this one, V out minus 0 divided by 10 over S. Alright, so now we have this equation, and we can rearrange this equation to have this now, and then we can actually make it simpler or simplify this equation by multiplying both sides with 10. Right. Next, we can reduce the equation till this form, right? We multiply both sides with 10, then we come to this equation and we rearrange them again to make it like this, right? Why? Because we want to get the V out. So here what we can do now is to use partial fraction decomposition, okay, because we want to separate into two fractions here so that we can refer to the Laplace transformation table. Alright, so basically using partial fraction decomposition, we can solve for A, which is 10, and then B, which is 15, and then finally we'll get V out is equals to 10 over S plus 1 and plus 15 over S plus 2. And then from here you can just simply refer to the Laplace transformation table to get see here is 10 E minus T for this plus 15e minus 2t, right? That's the answer for V out t. Thank you.